So, hi everybody. Welcome to Smells Like Legacy. I have no idea what he just said or what he told you about me. So, just to be sure, my name is Sebastian. I'm coding for roughly 30 years now. So, and 20 of those with PHP. So, quite a while. I'm doing some open source projects on the side. They are called Captain Hook and PHP-BU. If you want to, you can check them out. And just like everybody else, I'm saying stupid stuff on the internet. So if you care, you can follow me on Twitter or hit me up there. So, this one was my first computer, the Commodore C64. This was in the 80s, mid-80s, late 80s. And do you still remember the 90s? Yeah? So those were one of my favorite movies from the 90s. And in the 90s, this book came along in the 90s. Who of you knows this book? Oh, quite a few of you. Okay, nice. Who of you actually read it? Yeah, I know. Okay. And for some of this, it seems like this book is from the Stone Age of software development, right? It's ancient, it's from the 90s, we don't care about it anymore, it's old, right? But actually it's not the case. And I can only encourage you to give this book a read. It's really good. So the book was written by Martin Fowler, and he got some help for the book from Kent Beck. And Kent Beck actually mostly contributed to the third chapter, and that is all about code smells. I think everybody heard the term code smells, right? Code smells, kind of familiar? I see nodding, okay, perfect. And Kent Beck did a really powerful thing with introducing code smells. So I heard the guy before me was talking about code review. So sometimes in a code review, somebody might say, that doesn't feel right. You shouldn't do it this way. And that's always kind of weird talking about feelings when we talk about software development. So what Kent Beck did is he gave certain problems in software development names, and that's pretty awesome. So these are the 22 original code smells Kent Beck came up with. So these are problems that occur during software development. And he gave them quite cool names like shotgun surgery and stuff like that. And this was, like I said, in the 90s, like 2000 and something. Those two guys came along, those two Finnish guys. I won't even try to pronounce their name because it will not work. But they did a really cool thing. They made a study about the original code smells, and they kind of grouped them together. So they grouped everything, so we can ignore comments and the incomplete library client for now. And what they did is they made these groups of code smells. So let's talk about them. So the first group, we have a data clump, large class, long method, long parameter list, and primitive obsession. Data clump is if you have an app and you have two parameters in your app, and those parameters move through your application all over. You always have the same two parameters moving through your application. These two parameters are a data clump. For example, and we will see an example later, start date and end date, right? If you're always trying to work with start date and end date and move it through all your application, these two objects are a data clump. large class and long method. There, I think the name kind of tells what's happening there. And then we have long parameter list. And for me, long parameter list starts at like 3 parameters. So everything that has more than 4 arguments, maybe you should have a look at it. And primitive obsession, I see this in PHP quite a lot. Primitive obsession is, for example, if you have something that has a status and there's a database column for it, it's an integer, right? And you can have something that is in status 1, something that's in status 2, or status 3. And now all over your application you are asking, if status equals 3, then don't do that. But if it's equals 2, then do something else, right? And so you're completely obsessed with these primitive data types like integers or strings. That's what primitive obsession is all about. And those are called bloaters because they blow up your code. Those code smells make your code bigger than it has to be. So, bloaters. Next category is this one. We have alternative classes with different interfaces, refuse bequest, switch statements, and temporary fields. Alternative classes with different interfaces it's basically whenever you have to type check, right? If you have some method and you have to write something like, if is instance of, then do something, and if instance of something else, then do something else. This is the alternative classes. Refuse bequest is if you have a class and you're extending the class and you inherit some methods, and the first thing you do is write something like throw not implemented exception. So you don't want that this method is going to be called. Then you refuse the bequest. Switch statements are just like any other conditional. If statements, else can be a code smell. And last one in this group is temporary field. A temporary field is something, if you have an object and it has some property, and sometimes the property has a value and sometimes the property doesn't have a value. So it's sometimes there, sometimes it's not. And this group is called abusers because object orientation, just like any other practice, is only a set of tools, right? And you can use these tools in a wrong way. And what this gives you is it will always lead to you getting hit by the car someday. But yeah, so you shouldn't do it that way. So abusers done. Next group. The next group are divergent change, parallel inheritance hierarchies, and shotgun surgery. So divergent change is if you have a class and you want to change something in that class, and now you see, oh, if I change it here, I have to change it in the other method as well, and then I have to change it here, and then I have to change it here as well. So do a search replace on your class file. What could go wrong, right? Parallel inheritance hierarchies is if you have an object structure, and if you're adding an object over here or a class, then you have to add a class over here as well. And same, if you remove something here, you have to remove it here as well. So you have parallel hierarchies that are somehow linked together. And last one in this group is shotgun surgery. Shotgun surgery is divergent change on steroids. So divergent change was if you want to change something, you have to change multiple places in one file. And shotgun surgery is like changing stuff all over your repository. So your complete application, you have to change like 50 or 100 files to make that change happen. And those are called preventers Because what they are going, if you code, or if you have problems like this in your code, you don't want your code to change, because most of the time something breaks. So these are really things we want to avoid. Preventers done. Next group, a data class, duplicate code, lazy class, and speculative generality. Data class is if you have a class and it doesn't have any functionality, it only has data in it. And object orientation gets really, really powerful if you model behavior with it. And data class, it says, okay, this object doesn't model anything, it's just stupid. So why is it there in the first place? And now we get to a point where we have to understand that code smells can be a problem, but they don't have to be. Because, for example, value objects are really popular and really cool things. And basically, value objects are data classes. So they are code smell. But like I said, code smells aren't really hard rules. They only are indicators that there might be a problem or that there might be a problem in the future. So there are good decisions to say, okay, I know it's an original code smell, but I use the value object here. It's fine. So it always depends. So duplicate code. I think we don't have to talk about duplicate code. And lazy class is if you have a client object and you want to interact with that object in a certain way and want to do things with it, and you know it totally makes sense that this object would do something like this, but it just doesn't. Somebody was too lazy to implement that feature. It should have been obvious, but somehow it wasn't. So then we have maybe one of my favorites is speculative generality. So who of you have ever developed a feature that you thought would be needed in the future? So it's not needed right now, but it's needed in, I know the product people will come along in 4 weeks and they will want this. And who of you was wrong and that feature was never used, right? Okay. So that's exactly what speculative generality means. Like when we implement something and say, okay, I know it's not the feature request we're dealing with right now, but if somebody wants the next cool feature I'm thinking about, then we can write the code in a cooler, more abstract, more generic way. And what this does is it makes the code harder to read, right? It's not actually concerned about the feature that you should write. It's concerned about features that might come in the future and will most of the time never come. And since code is much more read than written, most of the time it's much more important that your code is readable than it's nicely written, or it is easy to write. So you should focus on readability. And speculative generality is kind of something that doesn't work with that. So these are called dispensables. So you just can get rid of them. You just don't need them. So up for the last group. Last group is feature envy, inappropriate intimacy, message chain, and middleman. Feature envy is if you have a class and it's much more talking to other objects than it is talking to methods of the object itself. It's always talking to different objects, right? It's envying the other objects much more than it's envies itself. And then there's the inappropriate intimacy. This is when someone tries to modify internal behavior or implementation details somehow not from the outside. Mostly it's done by inheritance. So you inherit something and then you try to manipulate the internal state somehow. Not nice. Then we have message chains. And message chaining is whenever you see the arrow operator in PHP, you're calling a method on an object and then immediately calling another method on the return value, right? So in JavaScript it's the dot, and in Java, in PHP, it's the arrow operator. And we will talk about it, why this can lead to problems. And finally, the last one is middleman. Middleman is it's similar to feature envy, but it's if your object is only forwarding stuff. It's not doing anything by itself, it's just forwarding method calls. It's received a method call and it forwards the method call to somebody else. And once again, we have this thing where actually there's a specific design pattern that's called proxy that's doing exactly that, right? It's taking method calls and it's forwarding them. So again, it's not a hard rule, but you have to decide, does it make sense here or does it not make sense here? And those are called couplers, because what they do is they merge stuff together. So you can't get anything out of your cool application and say, okay, I want to reuse this part, because most of the time, if you get the class out of there, then there's a lot of stuff coming with it, like a big tail of things that you rip out of it with it. So couplers, great. So these are the original code smells, and what's really cool about it is now we don't really have to, for a lot of problems, we don't have to say something like, this doesn't feel right, right? We can say, you have a shotgun surgery here, maybe we should do something about it. And if both parties understand what code smells are about and what they are, then it flourishes the discussion about it. It makes to talk about stuff much more easier. And but what if you discovered a code smell and you want to get rid of it, right? So now you have to think about what can we do with our software, and luckily we can refactor our code, right? And over the time, refactoring became kind of a bad word for business, right? So whenever you say, okay, we have to refactor this, business is running away screaming, no, don't refactor, it's terrible. And we are kind of to blame for that as a developer, because we call everything refactoring. Everything is refactoring. And it's not really a refactoring if we say, okay, we have to throw it away and write it all new. So a complete rewrite is not a refactoring. Refactorings are defined as rearranging code without changing the behavior. And that's very important. So refactoring is rearranging code without changing the behavior. And unit tests are kind of describing the behavior of our software. So when we do refactorings, it should be possible that we rearrange code without changing the unit tests. Whenever we have to change unit tests, sometimes we have bad tests, okay, then we have to change it, but normally it should be possible without changing the unit tests, changing behavior, without changing the behavior. So this is very specific. So, and we call refactoring just everything, and now everything is scared about refactoring. But if you don't change behavior with refactoring, then it's totally safe, right? Because you don't really change anything, you're just rearranging and cleaning up code. And it's kind of, our mission to get this, to set this right? To talk to business and say, no, refactoring is totally safe. We talk about refactoring in a refactoring sense, not in throw everything away and write everything new sense. And refactorings are actually recipes. And that's why the book is somewhat hard to read. It's like reading a cookbook from one to the end. You don't do that, right? You just use the cookbook whenever you need some special recipe. And so refactorings are recipes for code. And what all you have to do is you have to read the recipe and do what it tells you to do. And just like CodeSmells, refactoring also have names. And there are a lot of refactorings. They are refactorings for composing methods, moving features between objects, for organizing data, simplifying conditionals, simplifying method calls, and dealing with generalization stuff. We will not talk about all of them, so don't care. The very important thing is that if you have identified a code smell, there is a refactoring that cures this code smell. This is really important. There is a refactoring already recipe where it lists things to do to fix your code smell. So, and if you're like me, you can't remember all of them, then there's a cool website that's called the Refactoring Guru. And for example, you can just look on the left side. There are the code smells, and for example, there's data clump, and now it shows you, okay, we should use the extract class refactoring here. And if you click on the extract class refactoring, it will actually tell you what you should do with your code. And then you have some optional refactorings to follow that. But what that means is we don't ever have to think about fixing code smells again because you have recipes, right? You don't have to do crazy creative thinking, just follow the recipe. That's really nice. So you can focus on your business logic and more complex things, and just, if you have code smells, just get rid of them by doing the refactorings. But now let's actually look at some code. In this case, we are talking about some database object, in this scenario sale, so it can be stored somehow in the database. And then we have a foo class, and the foo class has a sales total method. So it returns a list of, or a value of what the company sold for a specific time. In this case, we have a start date and an end date. So we want to get something, all our sales, for a specific time. And then we create these persistence object, say, okay, we doing the database stuff, get me something with where, and then sum up everything, right? So we building a sum value at the end. And then we have this thing, okay, we know about the date column in the database, and we know about the cost column in the database. And then we create something that is called date range from start date and from end date. So not that bad, right? But like a week later, we have to create a bar class, and the bar class has something like weekly sales total. So we have only the start date, because for a week we can calculate the date range. So what we are doing is we have to create the start date, and we can calculate the end date. And now we're doing the exact same thing as on top, calling the persistence object, doing the database stuff with where and sum, and then same thing, we know about date and we know about cost, right? And of course, there's this date range thing in the middle again. Great. So now somebody says, okay, it's cool, we can do this with sales. It would be really cool if we could do it with the expenses as well. So business needs expense costs. Okay, so we write an expense class, like the sales class, and then write a report class bas with the expense total method. And then, of course, start and end. We're doing the expense stuff for the database object and creating the date for the date range. And that's most of the time fine, right? Okay, and now, kaboom, something happens. There's a bug report. Okay, bug report, great. Somebody's telling us in our bas class, there's something weird happening if we inserting wrong dates. Okay, so somebody's seeing the bug report, is saying, okay, now I have to validate what's coming in here, right? So, okay, let's do this. We can just do some basic validation and provide some defaults, and yeah, it will work again, right? The bug is fixed, everything's fine. And so now, this code isn't super bad, but now let's take a step back and try to identify some concepts that are in your code, right? Firstly, we have the concept that we can calculate a week, right? We can calculate how long a week is. Then we have the concept of validating dates. We can make sure a date is actually really a date. And then we have this date range thing where we can say, okay, it's a start date, and then we have an end date, and we can give this to the database. And then we have the database stuff, right? The where, the sum, and all of that. And then we have some knowledge about the internal representation, like we know the cost column and we know the date column. So these are the concepts that we have in our code already. And still, if it's only that, I think it's fine. But most of the time we start with a foo, a bar, and a bas, and then there comes a stinky, a curly, and a mo. And 2 weeks later, there's a Kirk, a Spock, and a McCoy, right? And like 2 months later, you don't have a clue what's happening in your code, right? It's really terrible. Yeah, let's refactor it. And the first thing we're going to do is we're identifying the data clump, and we're using the extract class refactoring. So let's look at our code. And the date range is exactly our data clump. It's always start date, end date, and we're doing some validations on it, but the validation is only in one method right now, and most of the time we copy it over to another method if another ticket comes. So now what we're going to do is we will extract a class and create a new object for it. And I'm terrible with names, so we have date range, so obviously we need a date ranger. And the date ranger accepts a start date and an optional end date, and it does all the validation. It validates the dates, and it has a method like getRange, so it returns a range from start date to end date, and it has a method getWeekRange, so it can actually calculate the week range for you. So this is the date ranger now. And now, of course, we have to use the date ranger. For this, of course, we say, now create a date ranger and just give me the range for start date and end date. And suddenly, we have the validation in here as well, because the validation is now completely handled by the date ranger. And then we can get rid of all the date range creation stuff below. And now we can do this for bar as well, of course. So we are going to bar, creating the date ranger, getting the week range from the ranger, and using that range. So last one as well, so bars. The validation can go as well, so we don't need the validation anymore because it's handled by the ranger. And now we can just create the ranger, get the range we need, use the range, and the code is much cleaner and much nicer to read. So now we have this code, right? That's quite nice. And this, the green parts, this was our data clump, right? This was start date, end date, date validation, and all that stuff. And now it's represented by the date ranger. So yes, data class, oof, extract class, fixed it. But of course we can do more. And now let's talk about methods chain. And we fix it with something that's called hide delegate. So where's the method chain in here? It's exactly here, right? We calling where on something, and exactly when, immediately after where is delivering us something, we call sum on it. And that's actually the method chain. So let's talk about this in a little bit more detail. So this is our code, right? We have some foo thing over there that is talking to sale and is calling the where method. And where is actually something it inheritance from persistence, right? So this where stuff is going to the persistence. And persistence is maybe somehow returning a collection or something. Who knows what the implementation is? But what sale does is it returns the collection directly to the foo guy outside. And now the foo guy can talk to persistence, right? This is now possible because the foo guy has persistence in his hands and he can talk to them. And he doesn't know anything about what they are talking about. So maybe that's not what the sale guy wants. And that's not what we want either. So it's like, if you think about it, it's if sale takes persistence and throwing it in the face of the foo guy and say, do whatever you want with him, I don't care. And that's not a very nice approach, right? On a more serious note, if you have a class foo, and foo has collaborators, right? Objects that foo interacts with. In our case, we have the date ranger, and we have sale and where. So these are called the immediate collaborators. These are the objects foo actually interacts with. So this is, but in our code we have this as well, right? We have sum. So this is happening on some collection that is returned by where, and now we are not only dealing with our immediate collaborators, we are dealing with our collaborators. And if you are writing unit tests, this is really annoying because you have to create mocks in mocks in mocks in mocks, right? You have to mock the whole world, right? And more soon than later, it will bite you. It will completely bite you. And this is actually what keeps you from writing unit tests, because it's complicated to write unit tests for software like this, right? And it's not that writing unit tests is complicated, it's that writing unit tests for complicated software is complicated. So we shouldn't write complicated software, so then we don't have to, writing unit tests becomes much easier. So so now we identified the method chain, and how can we fix it? In our case, like I said, we're doing it with hide delegate, and if you have something that's the same prefix or suffix for methods, then most of the time there's something there that you can refactor. If you see methods in a class that have the same prefix or suffix. Most of the time it's a hint that there's something to improve there. And what we're going to do is we are creating a total method on the sale class. So now we don't actually call where and sum anymore. We are calling total and just giving in the range. So the foo class doesn't know anymore about the implementation detail of cost. It just knows that there's a total method and we should give it a date range, and then we're fine. And of course, we do the same thing for the weekly total sales. And then of course, we have to do it for expenses as well. So expenses gets a total method as well. And then we can update our BAS class to use the total method. So now it's this way. It's, again, method chain is gone with hide delegate, right? And now we don't have to create mocks for these collection classes in our unit tests anymore, because foo doesn't know about the collection or doesn't return it. So we only have to create mocks for sales. So and just let's talk a little bit more about testing. If you're writing unit tests, in this case, we have the sales total method, right? And it actually creates a new object here, a new sales persistent object. And this sales persistent object is actually connecting to the database and is trying to read data from the database. And when you do this, let's write a unit test for it. What you have to do is you have to create this foo and put some values in it. And most of the time when you actually use the database in your unit tests, they are getting slower and slower and slower. So what happens is nobody will use the unit tests anymore because they take forever to run. And that's not what we want to end up with. So it's always nice to use dependency injection in this case. So in our case, we have like this new sale, and we have total. And the foo class only wants to call total. It just needs the total value. It doesn't really care about the foo thing. We just want to call total. So what we can do here is we can actually just use a model here, some model that we get from somewhere. We will get it in a second, and just use call total on that one. And then, of course, we are now able to create a mock for our sales object, a sales mock, and this is now much faster than before. And that's why dependency injection is really important and really powerful concept. Just inject the objects you need, and so when you have to mock them, it's much easier to do so. But it's very important to note that wasn't the refactoring anymore. Because what we did, we changed the signature of our method, right? Now we need to get the model as well. And so we changed the behavior. So this was an optimization and not a refactoring. And now we have to maybe change unit tests, we have to change some stuff in the implementation, and the application has to change on different places. So optimization, not a refactoring, but worth it anyway, because your tests will be a lot faster. But let's do some more refactoring. So now we're fixing some duplicate code we still have, and In our case, we still have class sale and class expense, and they look quite similar. And when we look at the thing, what we can do is we can actually create something that's called totalizing or something like this, right? And create a method for that one. And you maybe caught this one. I also added a second parameter to it with the on parameter. And maybe you remember that slide, especially the speculative generality thing, right? And now I'm guilty of speculative generality because I added a feature. Maybe sometime they want to sum something different than cost, maybe netto prices or whatever, right? And yes, it's speculative generality, but I think in this case it's small enough so everybody can understand what's happening in there. So I can, yeah, since code smells aren't rules, I don't break rules, but yeah, you understand, you get the point, right? I choose to keep it this way. And then what we can do is we can just use totalizing in our expense and our sales class, right? So, yay, duplicate code fixed with pull-up method. So we just moved the method from the original two classes into another class. So this was our code before, like a little bit blurry, and now we have the date ranger, we have a totalizing thing, still the sales and expense classes, and we have foo. And most of the classes look like this now. Yeah? We create a date ranger, we get a model, and we call total on that model. So in the beginning it was like this, right? But you shouldn't be like afraid, or you shouldn't dislike code that has code smells. Because you should embrace those code smells, right? You should really have fun with them, because most of the time, if you have identified them, they are really easy to fix because you only have to follow recipes. They are not complex problems to solve. Sometimes it's not difficult to do it in your app because your app is quite complicated and it will take some time to fix the code, but at least you know what you have to do, right? And then maybe it smells a little bit more like this and not that bad, right? Thank you.